Hello, David here, and this is the investigation of truck signal priority strategies using microsimulation. Freight transportation. This movement of goods plays a vital role in the Canadian economy, with trucks delivering 72% of goods produced annually. However, goods movement by truck carries some challenges. Trucks accelerate slower compared to passenger cars. This diagram shows a truck and a car stopped at an intersection, with the car further behind. 4 seconds after the light turned green, the car has entered the intersection while the truck has just reached the crosswalk. What is noticeable here is the headway between the two vehicles. A large headway can increase the travel time of the truck and any following vehicles. These delays can affect commuters that live or work in the region. More importantly, these delays affect the goods movement across Canada, impacting businesses elsewhere. So, how can we improve travel times on high truck volume roadways? Adding more lanes, it just adds more drivers, which further increases delays. A better option is to apply operational improvements to traffic lights. The goal of this research is to investigate TkSP strategies to improve car and truck travel time on a corridor in Peel. These strategies were tested using Visa microsimulation software. TkSP strategies are adapted from traditional transit signal priority. A literature review of TSP strategies was conducted to identify strategies transferable to freight. Green light extension and early green were transferable due to the high volume of trucks and the irregularity in truck arrival time. A green light extension was chosen due to its simplicity to implement, allowing for the green light on an approach to be extended if a truck is detected approaching the intersection. This green extension time was selected for our research. For the microsimulation, a 5-kilometer corridor of Dixie Road from Drew Road to Shawton Drive was chosen. Traffic data including signal timings and traffic volumes was used to populate the simulation. Detectors were placed to enable and disable TkSP when the truck enters and exits the intersection, respectively. Vehicle kinematics are calibrated to account for slower truck acceleration, and the roadway geometry was generated by tracing from Google Maps. Scenarios were generated for 2 periods of day, including the PM peak and PM off-peak. These tests included the base or do-nothing scenario, TkSP along North-South Dixie Road, TkSP along streets crossing Dixie Road, and TkSP along North-South Dixie except at Derry Road, where TkSP is placed along the east-west direction, known as the hybrid scenario. Here, you can see the microsimulation model running for the intersection of Dixie and Derry Road during the PM peak hybrid scenario. Most of the trucks on Derry are able to cross without stopping due to the green time being extended along Derry. From our results, the hybrid scenario had reduced travel time by 3.4% during peak and 5.9% for off-peak periods, with stops being reduced by 0.1 during peak and 11.7% during off-peak periods. 3 out of the 4 of the results from the hybrid scenario generate the largest reduction in travel times and stops. As such, the green light extension will be configured following the hybrid scenario. But it doesn't stop here. The initial model is being extended to include long combination vehicles. LCVs are a growing vehicle category in Ontario to allow a higher volume of goods to be carried by each vehicle. I would like to acknowledge that the original model and results were generated by Ravichandra Rampur as part of his Master of Science degree requirements. Follow-up results and the research report were prepared by me. Funding was provided by the Region of Peel as part of the Smart Freight Center CLUE initiative. Thanks for watching.